Okay, performance in athletics. We're now looking at 100-metre sprint. So initially we've got this modelled by a linear equation. So looking at a straight line. And we're looking at t seconds is our world record, and n is years after 1900. So we're starting off with sort of what stuff means and what it tells us. So 2a, the meaning of 10.6, that's going to occur when n equals 0. So that's going to be in 1900. So that tells us that the world record in 1900 was 10.6 seconds. Then we have this number, and this number on a graph would be your gradient, so it's going to be a rate of change. It's going to be how much it decreases, so it tells us that the world record is predicted to decrease by 0.008 seconds each year. So as the thing on your x-axis goes up by 1, the thing on your y-axis, which is seconds, goes down by this much. Okay, so use the model to find a prediction in 2009. So first off, we need to know what year that is. So for 2009, that's 109 years after 1900. So if we substitute that into our equation, we've got minus 0.008 109 plus 10.6. So t is going to be 9.728 seconds. Okay, so we're now onto our new model. So we've got this model, and we're being asked what's the meaning of this 10.6. So again, when n is 0, that means e to the power of 0 is going to be 1. So that gives you the initial value. So in exactly the same as in part A, it tells us that the world record in 1900 was 10.6 seconds. So it's exactly the same as the meaning in part A. Okay, so part D, we are again looking at the model in 2009. So n is still going to be 109, and when we substitute this in, we've got 10.6 e to the power of 0.1238 109 So t equals 9.71 seconds. Show that this can be written in this form. Okay, so we start off with t equals 10.6 e to the minus 0.1238 n. We're going to learn both sides. So we just write it out with a learn in front of it. We can then separate these. So if we separate those, they become an add. These two are inverses, so they cancel each other out. Minus 0.0008 n, which is what we wanted. Hence or otherwise. Hence or otherwise basically means this is the most sensible way to do it, but if you've got another way that works, that's fine. So we want to find the year in which the model predicts it's going to reach that. So t equals that. So if we substitute that in, we've got ln 9.8 equals ln 10.6 minus 0.0008 n. So if we take that from both sides and then divide by that, we'll end up with n equals 126.4, and that is in years after 1900, so that should give us a year of 2026. So it'll happen somewhere in the year 2026.